individual, or you can make it united. I am going to have 3 examples for you right now, and I'm going to solve them all by myself. But maybe in between, I ask you to calculate something for me or ask what's your idea for like calculating some parts. So assist me with that one. Okay, it seems that I have just this place to work on that. So a rectangular channel, just something like that, have a bed a slope of 1 in 1,500. So I will write exactly what it says. Assume C is 50. Using the maximum discharge of this cubic meter per second, find the dimension of the rectangular. So it seems that it asks for B and Y. Right? Did I miss anything? No, it seems. So if you were me, would you go for Manning or Shezi? Stupid question. It says Shezi, right? It says use Shezi. If not, it gives you C. Manning doesn't have any C, it has N. So I will start with this one. C area RS. That's the Shezi formula. I need to write Q. I have it already. C, I have it. S, I have it. I don't have area and R. But if I start finding area and P and R, I will have problem. Why? Because I don't have Y. I don't have B, which means that I cannot calculate that. But there is a hint here. What is the hint? Hint says the optimum dimension. It means that it's giving me the hint that you should go for the best hydraulic section, most efficient one, optimum. And in the optimum one, if you remember, it was Y over 2, for example. Or if you remember, let me write it here, B was equal to 2Y. So instead of BY, I will write 2Y multiplied by Y. And I will write it here, optimum, which is B equal to 2Y for rectangular. And I will erase it from here. So instead of that one, I will write 2Y squared. Instead of P, which is B plus 2Y, I will replace it 2Y plus 2Y, which is 4Y. And R is already there. Or you can even calculate that. If you calculate that, he will end it up here. So I'm going to replace the data that I have. For this charge, I have this. For C, I have 50. For area, I will replace 2Y. For R, Y, and for S, I have this. So it seems that you can find Y easily, which is 0.611. Yeah. And for B, you will have the 2Y, which is 1.22. And be careful, when I said dimensions, it means that I need all the possible dimension. If it's trapezoidal, I need Z as well. But B and Y are required for sure. So just don't go for Y, calculate B as well. So that's a mixed of two concepts, using Shezi and best hydraulic section mixed together. I think pretty easy one. This one is the solution that I'm going to post. And next one. This is a trapezoidal channel. You have the side slope of 3 to 4 vertical, 3 horizontal, 4 vertical. A slope is given to you here. What is this number? Discharge or velocity? Which one? Discharge based on the unit here. Velocity is feet per second, feet per minute, meter per second. And you have C, and even it mentioned that use Chesy. Before I solve this question, do you remember that I said for Z, V always says Z is the horizontal over 1. Otherwise, you will confuse. Now it says that it's 3 horizontal, 4 vertical. So I try my best to make it like the pattern that it's easy for me. So it's 4 over 3. I will change it to 1 over 3 over 4. So I change it to have 1 vertical, everything horizontal. I have the picture here and I write everything that I need. So S is 1 over 2000. Z is 3 over 4. Q is 0.5 cubic meter per second. It asks for B and Y. And again, as you can see, it says what is the optimum dimension. So it means that without considering the optimum, you cannot solve it because you have no Y, no B. For trapezoidal, if you remember, it was that T was as twice as wetted perimeter. So T is twice that. If you check the table that you have, B plus 2YZ, which is your T, should be as twice as Y plus 2Y Z squared. So this is T, this part is P. I will keep B one side. So 2 what's that? Minus 2YZ here. I think I wrote it. Yeah, that's not correct. Just give me 1 second. You don't need that one. P was 2Y. Yeah, that's correct. So that's correct. B, I'm keeping that part. So, and you don't need 2 here as well. Just 1 here. So maybe I can shift it a bit back. Y 1 plus Z2. That's right. So 2Y 1 Z2 minus this one. Seems correct. Yeah. So I have Z. If I replace Z, it means that I can find the relationship between B and Y. So I don't have it, but I have z, which is 3/4, which is 9/60, minus 2y multiplied by 3/4. If I simplify that, probably I will get b equal to y. You can double check it. Do that one. Let me double check. 9 plus 16. So that's 4. 5/4. Correct. Don't write them. I'm just double checking. 5/4. 5/4. Yeah, that's correct. So based on what is the definition for best hydraulic section, you will ended up the relationship between B and Y. Now you can start finding area, P and R. For area, for trapezoidal, you have BY plus Y2Z. Instead of B, you can replace it with Y. If you do that, for area, you have this number. For P, B plus, do I have P here? Did I calculate P? I think I don't even need that because at the end I need R, which I know that one for R. So probably I don't need even to find it. And I will keep that one. So I will start writing Shezi and I will write it for you. We don't need it. If you want, you can find it and then divide it. But based on table, you know that what's the best hydraulic radius. So Q, C, A, R, S. Do I have Q? Yes, 0.5. C, yes. Area, I have it. And R square. And for this one, I have. If I do that, I will ended up finding Y. And I will have B as well, which is equal to that. And I will tell you something about that. Two things that I insist, don't forget. Again, for Z, make sure that you have one vertical, everything Z. So horizontal. If you have something like that, change it, divide it by anything, multiply it by anything to make sure you have the number for horizontal, one for vertical. And in this case, you can easily write Z, the number that you have for horizontal one. Two, the best hydraulic section for trapezoidal says that T should be equal to twice of side wetted perimeter. So maybe it's not good to write perimeter here, write sides here to make sure, because perimeter is B plus 2Y, this number. And as you can see, I don't have B here. So just sides perimeter. So I will add sides here to make sure that when you study, don't write B plus. And if you start replacing everything until when you get the relationship between B and Y, it seems that your job is easy. You just need to replace everything in Shezi. Just make sure that you have the relationship between B and Y. Otherwise, you cannot solve it. And that's the solution for this one. It used D for Y. So make sure when you study that, D stands for depth. I think we have one more example as well, right? Yeah, that's one. This is the last example before I start 5C officially. Again, trapezoidal gives you the Q, N. So it seems that there is no Shazi. N is for Manning. You have S, and again, be careful. Some books shows the side slope bar with M. So M is exactly D. Design the channel. Design the channel means that I need to know B, I need to know Y. So I need you to give me both of them. And for Z, it is like 3 to 3 over this one. So you can make it like that one and write Z equal to 1.5 or 3 over 2. Both are correct. So I will write everything that I have for this one, and I hope that I don't make mistake for that one. Q10 cubic meter per second. S was 0.0004. Z or M, I will write both 1.5 or 3 over 2, N is 0.014. This is all I have. For this question, I cannot go for the previous method and says that I will write B and Y related together. So I should start from scratch and make the differentiate of P over Y. So area BY plus Y to Z, which is B plus, instead of Z, I will write this one, multiplied by 1. P B plus 2Y multiplied by this guy, which if I replace that, it's B plus 3.61Y. The rest are numbers. So instead of Z, I will write 1.5 and the rest is there. From here, because I like to have B based on Y, I will write B based on area and Y. I will call this one number 1, number 2, because probably I will use them later. So I want to reference them when I'm using them. So P is equal to, instead of B, I will write A over Y minus this guy plus 3.1Y, which is A over Y, negative here, positive here, 2.11Y. Now I can start differentiating. EP over dy should be equal to 0, optimum or best hydraulic section. So d of A over Y plus 2.11Y over dy should be 0. Solve it. We will end it up area equal to 2.11 y2. That's your area. Use equation number 2 because I want to see what will happen to B. B is area over Y minus 1.5. Instead of area, I will write the one that I have right now. 1.5, and I will have 0.61Y. So I have this one, and probably I need R as well, because I'm going to use Manning. 2.11 Y square over, did I calculate P somewhere? I can do it for you. P is 0.61y plus 0.61y, which is 4.22y. That's your P. If you have R, again, you will get the same R. So you don't need to calculate R for the best. R is always going to be half of Y. Do I have one more? No, I should place everything here. So officially, I didn't do anything like magic. I tried to find everything based on Y. Do whatever you can to get area based on Y, perimeter based on Y, hydraulic radius based on Y, because at the end, you should replace those either in Shezi or in Manning. And you don't want to have anything like B in your equations. So discharge, I will use 1 because it's metric or SI. Area R 2/3. Yes. Do I have discharge? Yes. Do I have Manning equation coefficient? Yes. Do I have area? Yes, based on Y. Do I have R? Yes, based on Y. And for S, I have 0.004. If I do that, I should ended up these numbers. Y is going to be 1.86 million. Since it says design, I need to have area, B, T, and P. For area, if you remember, you had 2.11 Y2, which is going to be 7.3 square meter. For B, you have 0.61 Y, which is 1.18 meter. For T, you have B plus 2YZ, 6.71 meter. This is going to be. And for R, you can just say 0. So that means designing area, TP, B, P, and everything that I need for this one.